Okay. So I guess before I start and before I introduce myself, a show of hands, who is working or has an interest in wireless communications, namely like 5G and ORAN? A couple. Okay. Who of you have heard of SRS and or our software? Okay. Okay. That's good. Right. For those of you that don't know anything about us or anything about our software, hopefully today will provide you with some sort of an overview and maybe pique some sort of interest in what we're doing. So, a little introduction about me. So, my name is Brendan McAuliffe. I'm an application support engineer at SRS. I'm originally from Ireland. So, if anybody struggles with the accent or I talk too fast, let me know. Um, I graduated from Trinity College in Dublin in 2020. I did a master's in telecommunications and then started at SRS 4 years ago. So, I'm relatively fresh into industry. Today is actually my 4 year work anniversary, which I realized after giving the talk to the guys this morning. So yeah, pretty new and not far off where some of you guys might be currently. So that's enough about me, I think. So a little bit about what we're going to talk about today. Firstly, I'll give you an overview of the company. So who are SRS, what do we do? Then I'll talk a little bit about 5G and Open RAN, maybe for those of you that don't know what that is or might have a little idea, but not a whole lot. And for those of you that already know, you can take a nap for that 5 minutes. I'll then also talk about open source. So what is open source? Why is it important? What does it mean? I'll talk about the code, so srsRAN project. And then I'll talk a little bit about developing an industry. This is, I guess, something that I think is quite important. I often feel that I didn't have enough exposure to what industry actually looked like when I was in university. So hopefully I can clear up some of that for you guys today. And then I'll do a small demo to, I guess, solidify what the hell srsRAN project is. And yeah, well, we have a couple of phones here that are set up, so you can come up and have a look at that. So let's get straight in. So who are SRS? Who are we and what do we do? So we're an Irish company, a private company founded in 2012. We were actually founded in Trinity College, Dublin. So we're a spin out of the Connect Research Centre. Started by two guys doing their PhD. And now we are a company of, I think, 25 full-time employees at the last count. We have offices in Ireland and in Spain. And we have a global customer base. So people from Europe, Asia, and the Americas. Like I said, we're 25 full-time employees. About 21 of those are full-time developers. The other four of us are kind of, me and some other people that are doing more customer-facing work. We're 100% software radio. Who knows what software radio is? Show of hands. Okay, very good. For those of you that don't know, you will know by the end of this talk. And we've grown organically. So we have no venture capitalist funding. We have no backing beyond the contracts that we have and the work we do. So there's nobody pulling the strings, only ourselves, which is quite a nice place to be. So as a company, we have these kind of four main pillars of expertise. So software radio, telecommunications, software engineering, and signal processing. So that means a lot of our engineers are from kind of various aspects of engineering. We have some people that did a lot of kind of maths, some people that did a lot of software engineering, and then some people in the middle who did a bit more telecommunications. And we all have an interest in software radio and open source, of course. So what do? We develop, we actively develop one product and maintain two. So we build 4G and 5G mobile wireless software radio systems, right? So these are available as both open source and closed source commercial licenses and products. And we currently have two main open source products. If you go through our GitHub, there are a few more other things, but they're not actively maintained. So we have srsRAN 4G, which some of you may know was formerly SRS LTE. So this is a full 4G software stack from the UE all the way back to the core. The UE, for those of you that don't know, is your user equipment, so your phone, and then the core network is the core network that connects you out to the internet. Currently, we are developing and maintain srsRAN project, which is a 5G ORAN compliant RAN solution. So in this diagram on the right, this is basically what a 5G network looks like, right? So you have your phone, which is what you have in your pocket, and you have the RU and the CU and the DU, which are the kind of the towers you connect to. So we developed the CU and the DU, and then that connects to the core and to the public internet. So we develop a small part of the ecosystem, but arguably the most important part. Get rid of this notification here. Okay, so how do we make money? That's, I guess, a very important question. So we work as platform providers in multiple publicly funded projects. These range from like European projects, like the Horizon calls, to contracts in the US and some contracts in Spain and in Ireland. So these are pretty big projects. I don't know how many of you are familiar with how these projects work. Maybe some people doing PhDs do know about these. They're basically government-funded projects or public body-funded projects that bring together large consortiums from industry. So you'll have people like Ericsson and Nokia. You'll have SMEs, so small medium enterprises like us, and you'll also have research groups. So like the Sense Lab here. Unfortunately, Switzerland isn't in the EU project call, so we don't get to work with you guys. But people like Connect in Trinity, and then some of the labs in UPC in Barcelona and everywhere else. So currently we're involved in 7 projects, soon to be 5. So Daemon and AI at Edge are finishing up, but the rest are continuing on for a while. These projects range greatly in what they're covering. So Trantor and Stardust are doing non-terrestrial networks. Daemon and AI at Edge are looking at how we can implement AI and machine learning into networks to create more efficient, sustainable, and scalable networks as we move from 4G to 5G to beyond. And then 6G, Blur, Dawn, and Oasis are funded by the Spanish government and are kind of doing a more ORAN-centric implementation for AI and ML. So looking a lot at the near real-time work for network optimization. Okay, and then in terms of commercial project, let me just go back here for a second, actually. So as platform providers in these, we don't actively research or develop new technology, but what we do is we go in and we say, look, this is an open source platform that's ready to use. Let's help you get set up with it and get working with it. And then we leave it to kind of the research groups to do the research and innovation. We then will develop like things that are in line with the 5G standards, or things that may already be on our roadmap. We don't do like we'll say crazy cutting edge research, but we do help people out. Because we're so small, we just can't afford to be doing research, so we stick to what we know and stick to what we're good at. So on to the commercial engagement. So we have a lot of commercial engagements. These are kind of the 2, I guess, most interesting, and 2 that are easiest to grasp. So we have one project with Smart Sky Networks. Both of these are based in the US, by the way. So Smart Sky, we have developed a commercial air-to-ground network for private jets. And for AST Space Mobile, we are developing a platform that allows unique direct-to-mobile 4G and 5G networks. So what that means is you will be able to use your phone to communicate with a satellite, which will then connect you to the network as normal. The use case for this is in maybe areas in places like the Sahara Desert, the Himalayan mountains, places where there's no existing infrastructure. You can basically light up an area on the ground with these satellites and provide direct to mobile communication. So there's no need to have a fancy sat phone or anything like that. You can use whatever's in your pocket. So a little bit more on these projects. So Smart Sky, like I said, is a commercial air-to-ground network. For this, we developed 3 products. So Smart Cart, which is basically a cart that you wheel under the plane. This communicates with the plane to make sure that it can connect to the network accordingly before it goes in the air. Smart Scope, which is basically a UE or a phone mounted on a drone that flies around and tests the cell sites when they're installed. And then Rocket, which is the ground station itself that we developed. So we took our code, which is written in C++ and is typically deployed on x86 platforms like Intel, AMD, all those ones. But this was deployed on NXP, on the PowerPC platform, so we had to modify it slightly to work on this. Currently, there's about 300 sites on the ground in the US, so covering the whole continental US. And there's about 15 planes. So that may seem a little bit underwhelming, But the problem with working with aircraft is that you have to go and get FAA approval because you're basically mounting an antenna on the bottom of the plane. So they're working to bring more aircraft models on board, which will in turn bring on more people. The target market for this is typically like business jets or people with a lot of money that want to be connected to the ground so that they can stream the latest Netflix movies. Other people are concerned with executing trades at high altitude while they're traveling coast to coast in the US. So yeah, interesting people, not us, unfortunately. AST then, like I said, this is a direct to mobile cell coverage with a satellite. So this, interestingly enough, uses the world's largest communication satellite ever deployed. It's a massive phased array satellite. I think it's like the size of a football field or something like that, or 3 football fields when it's fully unfurled. When they launch it, it's a box, and then it comes out like a fan. So currently they have one. So the Blue Walker 3 is deployed. That was deployed in 2022. And they are aiming to deploy a couple more by the end of the year. So what do we do in this? We basically put our eNode B, because currently this is using the 4G standard. We put our eNode B on the ground in a site in Midland in Texas, and it communicates with the satellite. So you can basically connect your phone to the network. It pings from the satellite, which acts as a relay and allows you to connect to the 4G network as normal. So we've done this as a proof of concept internally with AST, and that platform then is being used to demo to mobile network operators across the world who are looking to come on board with this. Just last week, they announced a massive contract with AT&T to provide coverage to AT&T users. So hopefully by the end of the year, we'll start to see some real world use cases with everyday users.
How narrow are the beams?
So the beams are roughly equivalent to a standard terrestrial site. So it's pretty good. It's not just a spot, right? It's a yeah.
How high the satellites are?
I don't want to say the wrong thing here, but they're like satellite high. I think they might be. They're not geostationary, I don't think. So they're actively orbiting. But again, I don't work directly on the project, so I don't know.
That's LEO. LEO orbit.
Yeah, maybe. Don't quote me. If you look at the press release, it's probably there somewhere. I should have preempted that question. Okay, so you've seen that we do open source work. So that is the kind of publicly funded projects, as well as research groups and normal everyday users, kind of hobbyists that just want to use the software. They can get it for free from GitHub. You've seen how we work commercially on various projects, but how does this work? Because essentially we're giving them both the same product. So the open source code is licensed under AGPL v3. I would remember that for later if I was you. And we license the commercial software on a kind of an ad hoc basis. So the license is dictated by the nature of the agreement between us and the commercial partner. So we don't have a kind of a set in stone, like this is how we work. So you have to contract support, and you have to contract the source code and blah, blah, blah. You can buy binaries, or you can buy the source code, or you can license us to do support. Because we're a small company, this is something we can afford to do. But obviously things that are developed under a commercial license aren't always put into the open source code, but anything that is developed in the open source stays there. So it's the same core package, just licensed differently. Okay, so moving on and maybe clarifying what the hell is 5G and what the hell is Open RAN. So this is the architecture like you've seen before, but let's get into details on how this actually works. So let's start from the start. What is 5G? So most of you are probably old enough and young enough to remember 4G. I don't know how many people remember 3G, and none of us probably remember before that. At least I don't. So 4G was defined in 3GPP release 8 in 2008. That was then implemented on, and LTE 4G Plus was defined in 3GPP release 10 in 2011. And then 5G was defined, or 5G phase 1 was defined in release 15. Also remember that one, in 2018. So you can see we have roughly 10-year cycles between Gs. So that means 6G may come in 2026, but who knows? Currently, we're in release 18, which is just an implementation or a kind of an advancement of 5G. So I guess what the hell does this all mean? This table should show that a little bit. So release 8, which was 4G, you had speeds of up to 100 megabits per second and latency of 60 milliseconds to 98 milliseconds. As we go through the generations and the releases, this gets a little bit better. So currently with 5G, the aim is 1 gigabit per second plus. In the real world, that doesn't always work out, but this is the aim. And a latency of less than 5 milliseconds. So you can see, as the generations go on, things are getting better, things are getting quicker, and you'll notice that in your phone. You go to some countries or some areas in Switzerland, I'm sure, where you're getting an older connection and it's noticeably slower. That said, I don't know how much difference we do notice as everyday users between 4G and 5G. But yeah, the telco operators will tell you that 5G is essential. Okay, so we know what 5G is, hopefully. But what is Open RAN? So Open RAN is a kind of a new initiative that came with release 18. And the idea is to basically, like open source, open the radio access network, create open interfaces, open blocks, to kind of, I guess, introduce more competition into the telco provider space. So ORAN, as the definition says, aims to define open interfaces and components for 5G RAN. And there's 4 main aims. There are various other aims depending on who you talk to, but these are kind of the 4 core tenets. So they want to promote interoperability. So this means that you can buy various things from various people, and the idea is that they just plug and play. They want to reduce costs. So like I said, more competition means competitive prices. This is good. It increases flexibility, so you can pick and choose things based on your specific use case. This is great for putting in things like stadiums, racetracks, universities. You can, pick the CU and the DU that does exactly what you need. You pick the RIC that does exactly what you need. You pick the RU, the radio unit that is capable of supporting your needs as well. It also aims to enhance security. This is brought on by, many of you may have seen in recent years, this kind of concern around people like Huawei and ZTE putting essentially listening devices into their network. By opening that up, you hope that you enhance security. So, as you open things up, especially with open source code, you come under more scrutiny, right? People can break your code and test your code and find vulnerabilities, and then you go and fix it. Because if you leave, vulnerabilities out in the open, people no longer want to use your code. The same goes for RAN equipment in Open RAN. Okay, so how has the architecture changed over the years? So you'll see on the right, the first image on the left is the kind of the standard 4G architecture. We had the 4G core, the baseband unit, and the RU. And then in 5G, as we moved to ORAN, this got further separated. So the core moves to a 5G core. The E node B, the VBU, becomes the CU and the DU, which is now called a G node B. And the RU, the radio unit, and it becomes the ORU. So this was all introduced in release 15, and we call this a functional split. So there's many kind of flavors of this. The one that you see here is split 8, but the most common one that you might see in a real world deployment is called split 7.2x. The X can be changed for A and B, and those things change different things within the network. But these are the 2 most important ones, I guess, for ORAN. Is that clear to everybody so far? I haven't lost anybody. I'm not talking too fast. No? Okay, good. I'm going to take silence as agreement here. Right. So expand that out even more. What does ORAN actually look like? So it's more than just a redesign of the G node B, right? What would be the point in doing that if you weren't going to have some sort of measurable gain or some other difference? So we've also added the following blocks to the ORAN architecture. There's a little bit more to this, but this is kind of the most high level image you can get. So we added something called a near real-time RIC and a non-real-time RIC. So one of the other core aims of ORAN was to make it easier to take advantages of AI and ML in advanced networks. So the near real-time RIC, so the RIC here stands for RAN Intelligent Controller. And that essentially is an intelligent controller that sits in the RAN and takes control of certain things. So the near real-time RIC acts at near real time. so it allows you to make changes on the fly. The non-real-time RIC, which sits out in kind of the orchestration framework, is more responsible for the overall network. The near real-time RIC is acting just kind of on the CU and DU. What exactly it does in those things depends on the use case, but as a whole, kind of the main use cases are changing things like bandwidth, so how much capacity a cell has, allocating more compute resources, because as we move to 5G and O-RAN, things become more virtualized, so everything is sitting on commodity PCs and big server rooms. So you may say, oh, look, this part of the network isn't performing very well, we better give it more hardware and more performance. With these new blocks, we obviously have to add new interfaces. So we added new interfaces to the core. I say we, but I mean, telecommunications as a whole, the 3GPP standards, not us at SRS. Added new interfaces to the core. We added new interfaces in the G-Node B, so the F1 and the open front haul. So these sit between the OCU and DU and the ORU. And then we added the E2 interface to the RIC, to the near real-time RIC, sorry, and then the O1 interface out to the orchestration framework. A lot of acronyms, a lot of letters. Fortunately, those of you that are familiar with telecommunications will know that we love letters and numbers for no reason. But there you go. Okay, so hopefully now we all understand 5G is, what O-RAN is, a little bit about SRS. But what is open source? Okay, that's what we do as a company. It's one of our main tenets and one of our main values. What the hell is it? Okay, so open source refers to source code that follows these principles. These are kind of very much summarized. Some people may say other things, but this should give you a good overview of what we mean by open source. So firstly, it's free. Anybody can download it at no cost, okay? You have open access to the source code. So when you download this, you can see exactly what's going on under the hood. There's no boxes, there's no blocks, there's no paywalls. You can see exactly what's going on. The development is transparent. So usually open source projects will have a roadmap that's available online. People that are coming to use the software can see exactly what's going to be implemented. Maybe not exactly when, but what's coming down the line. It should foster some sort of collaboration between developers and users. So in our case, we have a very active discussions forum. We have, active issues lists, and we also do accept some contributions back from the public. So there you have a clear collaboration between us and the user. And it's also community driven. This is something that we'd like to do a little bit more of, but unfortunately, it's the commercial contracts that pay the bills, so they dictate a little bit more about what we're going to be developing in the future and what we're developing now. But we get a lot of feedback from users in terms of what's the usability of the software. So things like the interfaces that you see when you run the code, how easy it is to modify, and things like that. So from that, we do develop certain aspects. But it is one of the main things that an open source project should aim to do, is to take feedback from the community and develop based on that. Okay, so why is open source important? You might say, okay, free software, great. What does that mean? Well, a lot like O-RAN, and what O-RAN means for telecommunications, O-RAN does a very similar thing for software development. So it's vital for new and emerging technologies. Firstly, being open source immediately gives you access to lots of people to stress test and play with your code. But in 5G and in O-RAN specifically, it's key to enabling the following things, right? So innovation. If we make our source code open source, it can be very quickly used by research groups like the group here and in other universities and research groups across the world to develop new features that are maybe ahead of the bleeding edge of what we're seeing in industry. It makes it more interoperable. So you might have something that you're developing in-house that you will start to use the code with. It's transparent. So it means that, you can see exactly what's going on. It's cost effective for a lot of people. So it may be very expensive to license source code or to license commercial code from certain people. But if there's a source code alternative, it means you can get up and running very, very quickly and get to work on doing what you're doing. It also is very flexible, and usually it's got quite a high level of customization that you can do with it. So yeah, that is that. Cool. Who benefits from open source? So you've seen what it allows you to do, but okay, that's great. What do we actually see from So pretty much all corners of, and we're talking in the realm of telecommunications here, but you can apply this to basically any area of industry that deals with open source code. So everyone from operators to end users are going to see some sort of benefit from the use of open source code. So operators will have more flexibility and reduce costs and faster innovation. So, they don't have to pay to buy code from somebody. They can just download this and get to work straight away. Vendors will have more opportunities, again, reduce costs and differentiation. So they'll be able to use different options from different people. Developers, so they get access to the latest features. Typically, open source projects develop a lot quicker than closed source projects. That's because you have to have something that differentiates you from a competitor that might offer a paid variant. So if you have the latest features, people will be more inclined to use your stuff. There's collaboration, so developers across different groups and institutions, and even internally in a team, it's much easier for them to collaborate. There's also a clear development process. Usually, this kind of means that you can clearly, as a developer, you can clearly see how the code you're using is being developed. But also, usually, if you're developing on top of an open source project, you will follow the development process that they're doing. So how are they coding? How are they developing? Not just the features they're bringing out. End users, so not the people that are actively using the code, but the people that are using the products that are maybe built on the code or have been inspired by the code, will usually see some sort of improvement on services and experiences. They'll see higher security. We've already talked about this. If something is open, it's under more scrutiny, and they'll see lower costs, right? If you're building a product that is built on an open source code base, you can market it for cheaper at the end because you didn't pay for it in the first place, right? Okay. Is that clear to everybody? We all have a better understanding of open source?
May I ask a question?
Go for it.
Is it necessarily free? Because you can have an open source software, sell it to somebody, it's still open, but they have to pay for it.
Yeah, so that is, I guess, one of the edge cases of open source, right? So in theory, you could take our software, put it in a box, attach a USRP or some sort of R front end to it, and sell somebody that box, right? But they're not really paying you for the code, they're paying you for the product, and paying you for the ease of having something that just plugs and plays right out of the box. You can't then, the downside for you is you can't hide the code, right? The code has to still be open source under the AGPL license. So it doesn't make a whole lot of sense to productize an open source platform for a third party, but we do see people that have done it. Okay, people have sold our software as part of packages, but there is a market for it. You just can't charge tens of thousands, right? Because why would you do that if the code is already there? Did that answer your question?
Yeah.
Anybody else? Feel free to just stick a hand up. No? Okay, cool. Right. So we've talked about the ecosystem as a whole, but what are we actually doing? So hopefully, based on what I've just said, I know it's a lot of information, you'll get a better understanding of what we're actually doing at SRS. So like I said, we're developing srsRAN project, which are these two icons you see in white here, and they sit in the 5G RAN. Okay. So we started development on this in 2021. And like I previously mentioned, we had a previous product called SRS LTE, which was a 4G end-to-end RAN solution. So we scrapped that, and we said, okay, this was good, but there's a lot of things we can improve on. 5G is coming, and we need a new product. So let's just start from the start. And we took all of our learnings and all of our failures and learned from them, and developed a brand new code base from the ground up. So we got not a lot of dependencies, but there were some dependencies in the old code that we said, look, let's get rid of these, let's make it all in-house, and let's have it work exactly how we want. So that happened in 2021, sometime in kind of the middle of the year. And then in 2022, we did nothing. At least to the outside world, it appeared like we did nothing. But then we came back in 2023, and we had our first initial release of srsRAN project. And that was, it was a pretty good offering, but a pretty juvenile solution when we look back on it. Although, it set the way for where we're going now. Then in May of 23, so about a year ago, we had our second release, our third release in October of last year, and we had our fourth release just at the end of last month, started this month. And with each of these releases, we are bringing out brand new features. And then in between all of these, we have a kind of a bi-weekly release schedule where we're bringing out small bug fixes, small improvements, smaller features that then get packaged up into the main release. And we release, I guess you can infer from this, twice a year. So usually in April, May, and then in October, November. So we have 2 tagged releases a year. Okay, so what is the architecture of srsRAN project? So if you look on the right, you'll see that this is just a more detailed view of the diagram we had earlier, right? So we develop everything that's in the blue box here. And so we have the OCU, the ODU, and that's it. But the interfaces between those as well, and that connected to the outside network. Right. So, like I said, we developed from the ground up, and we went into it with these 6 main ideas, right? That it was going to be a complete solution, so completely built by us. It was going to be portable, so you could run it on anything from a Raspberry Pi to a telco grade server. It was going to be performant, so it could perform at a commercial level. So you could plug this into a commercial network and it should work as intended. It should be open, both in terms of open RAN and open source. It should be flexible, so you should be able to put it on different platforms, do different things with it, bend it, break it, and it should still work. As long as you don't break it too much, then it won't work. And it should be interoperable, right? So you should be able to, based on the idea of ORAN, you should be able to take parts of our stack and plug them into other offerings from other third parties, and they should work together. That last point in practice is a little bit harder than you would think. We develop very, very closely to what's called the TS, right? The technical specifications of 5G. So these are like very, very big documents that basically give the building blocks for 5G. If anybody's read them, they're extremely painful to read. But they're the basis on which we build these networks. But the problem is not everybody does that. So sometimes you go to plug something in to something somebody has already built and it doesn't work. And so there's a little bit of hacking involved in that. But we do our best to be as tight to the spec as we can, which means that in theory, it's very interoperable. Okay, so what do we currently offer? Some of you are going to look at this and go, I have no idea what any of that means. Some of you will, but hopefully in a minute, we can kind of demonstrate some of the features and you'll get a better understanding. So we support both TDD and FDD. Hands up, who knows what those acronyms mean? Okay. I'm not going to go and try and explain them fully, but they're basically the 2 modes in which we transmit. So one transmits based on frequency changes or different parts of frequency, and the other one does it based on time. So this allows you to send multiple things at once without them clashing. Yeah, very hand-wavy explanation, but hopefully you get the gist. We support frequency range 1, which is a certain frequency range. You also have FR2 and FR3, which we don't support as of yet. So we support MIMO, which means that you can do 4 transmission and 4 receive channels at once. If you don't know what that means, it just means it can go faster. We support 256 QAM in the downlink and uplink. So these are the modulation schemes. Again, the higher you go here, the higher the throughput you have. For those of you that don't know what that means, as an end user, your phone is faster. We support intra-GNO B mobility, which means you can do handover between cells. We have support for NTN, so non-terrestrial network geostationary satellites. We do some E2 stuff, so we support some of those service models, which allow you to communicate with the RIC. This is, as some of you may know, one of the harder parts of developing an ORAN. The E2 is kind of the silver bullet for ORAN, they think, but the development around it is very hand-wavy because there's not a lot of options for RICs to test against. But that is another talk for another day. We have a custom open fronthaul interface, so that means that we can basically plug into commercial grade radio heads, radio units, without the need for dependencies on Intel and DPTK. So basically we created our own library, our own interface. That means you could basically run, if you had the correct equipment, a telco grade network from a laptop, right? Usually you wouldn't do that, you'd use a server, but in theory you could. We support hardware acceleration, so things like look-aside hardware acceleration, the ACC 100 from Intel. And in terms of performance, we can do 64 phones connected to one network, one cell, operating for more than 24 hours. At about 1500 megabits per second in the downlink and 200 in the uplink. Again, don't worry if you don't know what those figures mean, but they're good, I promise. So as we move forward, we will be developing some new features. So right now, the CU and DU, so those parts of the ORAN network, they're currently clumped together. In the coming months, we'll be taking those apart, adding the interfaces, which means that in theory, you could plug in a CU or a DU for somebody else with ours. The quality of service, so providing better quality of service on slices or 4 slices, aligning with NTN release 17, some power control, some more handover, some RAN slicing, the OWIN interface, which allows you to interact with the SMO, beamforming. I don't know how many of you might be interested in that. More MIMO and FR2, which is a higher frequency range. We're also looking to integrate with more third-party CUs and DUs, and then RE2 interface to test with other rigs. Okay, so now I think you should all have a better understanding of what we develop. Again, I know a lot of acronyms and a lot of words and a lot of new ideas. Hopefully you have a better idea. Yes, question?
You mentioned beamforming. Have to support only batch beamforming or general stuff?
I'm going to be honest, I don't work in the file layer, so I don't know exactly which approach we're taking. I just know that it's there. But if it's something you're interested in, then you can shoot me an email and we can I can link you up with the guys that do it. Yeah, sorry, I'm not going to pretend to answer because it's not worth it. Right, so if you're using the code, the open source code, these are kind of the most important places to go. And to be a good open source project, these are things you should have, right? Because if you don't have these things, nobody can use your code. So we have extensive documentation, which is what I'm responsible for mainly. So this has everything from like user manuals, how to use it, developer guides, how to navigate the code, what does it look like, to tutorials on, how to connect a phone, how to use hardware acceleration, how to connect to ORAN ORUs and all that kind of stuff. So the idea is that basically anything you want is in the documentation and there's a guide for it, which should step you through most things in about 5 minutes. Then we have the discussions page. So this is on GitHub. Who's familiar with GitHub? Everybody? Thank God. Very good. That's great. Some people aren't. You'd be surprised. So we have a discussions page on this, basically where the community goes to ask questions, answer questions, or just shout into the void because their code doesn't work. 2 of the guys here are very active on it, and we're very thankful for that. But we also do our best to get on there and help people out. Okay, that's it. So boring part over. Hopefully you learned something. And now I'm going to talk a little bit about how you actually develop in industry. So what does it mean to be working in an industry and developing? And one thing I have here is small teams, big results. So we are, like I said, a very small team of 25 people, but we have some pretty big results. So you don't need to be in a team of 100 people to see results. If you're all driven and you're all on the same page, you can do very, very well with very few people. That being said, some of them do have to be very smart, which helps. So how does it work? So for us, like I said, we have a team of 22 engineers focused on developing and testing. I'm not one of them, but I do work very closely with them, so I understand very well what they're doing. And I have done small development work throughout my career, so I am somewhat qualified to speak on this. So we have 3 main teams within those 22 people. We have a development team, they're developing the code. We have a testing team who are testing the code, arguably the most important part, and the integration team. So they're working on integrating our code with different pieces of hardware, different compute platforms, different phones, you name it. So everything we have is written in C++. Who's working in C++? Very few. Okay. What languages? Python? C? Okay. C and Java. Okay. Computer vision, I guess. We also have some MATLAB and some Python for testing and scripting. But the products that you get, srsRAN project, is all written in C++. And I think we have something like 1 million lines of code across all of the parts. So yeah, if you're bored sometime, maybe you can read all those 1 million lines. Right. So what languages and tools do we use? So our main languages, like I said, C++, CMake, which is our build environment, MATLAB, which we use for testing and prototyping of the physical layer. So that's the bit that actually handles the RF signals. We use Python for our CI/CD and our emulation, and we use Bash for scripting. Bash is probably more powerful than you realize, and it's very good to actually, practice using that. It'll save you a lot of time. Then in terms of tools, so what are we actually using? Git. So everything is on Git. The code is on Git. We use GitLab internally for our kind of private repositories and our CI/CD framework. We use Kubernetes. Hands up, who's using Kubernetes? Brave souls. Well done. We use Docker, GDB, Valgrind for memory mapping and testing, Google Test, and then ASAN and TSAN. Okay. So, believe it or not, this is the most important step in developing for any industry or any platform, CI/CD. Without this, there's probably no hope that you're going to have a deployable product at the end of your hard work. So this is something that we do all the time. We're continuously integrating and continuously developing. So everything we write gets tested. We test nightly, we test weekly, and then we have larger tests before the public releases. It's not maybe the type of engineering and development that everybody wants to go into, but it's definitely something that you should be familiar with, and at least have a basic understanding of this diagram. Because without it, there's no hope. I don't know how many of you have submitted something and realized it doesn't work at the last minute on some weird edge case. If you do a bit more of this, then you're less likely to have that problem. Okay, so that's enough about what we do. What are some things that they don't tell you in university before you go into the wild? So some of these points come from my colleagues, some of them come from me. But things you should learn how to do. So you should learn how to review your own code and code from other people. So I don't know if you do a lot of pair programming here. I know I did when I was in university. It's very helpful, not only to understand how other people develop, but to kind of get used to reading other people's code, right? We all code differently. We all use different kind of styling syntax, indentations and stuff like that. And we all have our preference for variable names, things like that. So getting used to those things can be very, very helpful, especially when you're dealing with large open source public projects. Linux and command line, if you're not working with that already, you should probably get comfortable with it. Linux can be very scary, but it's actually quite useful and quite easy to navigate once you get the hang of it, especially the command line. So if you have the option to use that, I probably would get used to it. This third point can be controversial. I hope there's no lecturers here. But focus more on the tools that you use rather than the data structures and the algorithms. Those can be learned, right? You can learn those at any time. But actually getting comfortable with using tools like Git and so on, that will serve you more as you get into industry. Then get comfortable with scripting and analysis. So things like Bash and Python. Learning logic is more important than learning the language. Think like a programmer. This is probably the most important piece of advice I ever got. If you think about it, you can learn one language, right? And you can learn one way to program. And as long as you understand the logic behind it, you can probably pick up any language very quickly. So this is something you should focus on. It doesn't matter how many fancy things you know in C or C++. If you don't understand the logic behind actually building algorithms, then what's the point? Pick an IDE and learn how it works. So whether that be something like VS Code or CLion, just pick one that you like, get used to using it, learn how it works, learn all the kind of embedded features they don't tell you about, and become as proficient as you can. There was a point that came to my mind. Yes. So something that's not written here, but something that I learned very quickly when I came to industry, especially working in something like telecommunications and 5G. You don't know what you don't know, right? And it can be very scary to admit that you don't know something, especially when you're new and you're trying to impress people. But don't be afraid to ask the stupid question. You would be surprised the questions that we get from our team and when we have internal meetings from people that you would think might know everything. So there's no such thing as a silly question. I know people say that all the time, but believe me, it's true. If you don't know, just ask. It's better to admit that than pretend you know something and then get cut out later on.
I can jump in on this slide. If that resonated with any of you, like, oh shoot, where did I learn this stuff? Those actually got workshops on using IDEs, Git, VS Code. So we'll cover a good half of these next minute.
Unfortunately, we don't have any tutorials on this, so talk to Eric about that. Okay, so that's things they don't tell you. But what do I actually do? So yes, I develop an industry, but I don't develop code, right? So developing looks like lots of different things. I do a lot of documentation, so this is essential to the user experience, and it requires a deep understanding of the code or whatever code you're working with and its features. So yes, I may not be writing these things, but I have to understand them, right? Project management. So this, again, you have to understand user needs, but also the features and limitations of the code. Like I said, you don't always have to be an embedded developer to develop on the code. And then you have to be able to communicate effectively with the development team. That's a skill in of itself. As an engineer, communicating with other engineers is easy. But if you're not an engineer trying to communicate with engineers, good luck. It can be very, very difficult. And then a lot of user support. So understanding how to fix issues from very simple to very complex. Someone might say, "Oh my God, my code doesn't build," and the answer to that is go and read the manual. To something complex like someone who's trying to implement a new feature and they get stuck. So with this, you need to know where and how to find solutions to these issues. They can be very easy and solved in a matter of minutes, or they might take hours, days, or weeks. But all of these things, they go back to those kind of core tenets of what it means to be a developer. So like I said, you don't have to be developing code. You do have to have that kind of developer mindset, I guess, a little bit. So that's pretty much it. Hopefully that wasn't too long or too boring. Does anybody have any questions? It doesn't have to be with the code. It could be about something I said or a general question on industry, like finding a job, anything like that. No? Okay, very good. If you don't want to ask a question in front of everybody, feel free to come to me later. I know it can be sometimes intimidating.
I have a question.
Go for it.
So you mentioned those things that people should know from industry. Is there a way you test those in interviews, or what would you look for when you interview candidates?
So that's a tricky one for me to answer because I have not interviewed anybody, but also the interview process at SRS is a little bit different. We're kind of a smaller team, so we don't have this kind of like 3 and 4 stage interview. But yeah, I mean, it's hard to know, right? It's dependent on, is there a specific part of that you were referring to, or?
No, I'm just curious what other people were wondering. Yeah, how you evaluate that know-how.
So this know-how.
This know-how, or maybe it's on the theory and components of
this kind of stuff.
Yeah, this stuff as well too. I mean, or how were you interviewed?
So mine was a funny story. I reached out to Paul, our CEO, on LinkedIn, and said, "Hey, I've just finished my master's, and I'd love to have a chat about industry. I did not ask for a job. I just wanted to talk to somebody in industry to get some feedback on what Ireland was like in terms of telecommunications. Did I have to go to America? Did I have to go somewhere else?" And we had about an hour-long conversation, and then he offered me a job. So he said, "Hey, we need somebody to do user stuff. We need somebody that understands this, but also is competent enough to, go and be user-facing." So yeah, I took it, and here I am. But yeah, I don't know. I can't speak for larger companies and how they work.
I think for smaller teams, that's
yeah.
Quite.
Yeah.
I mean, that happened to me. That I got my first job through GitHub, essentially.
Yeah.
So reaching out, cool messages.
Yeah, I guess the moral from that one is don't be afraid to reach out. If there's a company you want to work for, just do it. The worst they can say is no. Maybe don't say, "Hey, give me a job." But if you say, "Hey, let's have a chat. I'm interested," especially if you've mutual connections, that can be very good. But your network is your net worth, as I say. So make connections, meet people, and don't be afraid to talk to people. You're your own salesman. So nobody's going to know your capabilities if you don't tell them. I think a CV, I have various opinions on that. But your CV isn't going to get you your job. It's you as a person. So go and put yourself out there, and it'll pay dividends.
The trick is to be indirect.
Yeah, but I mean, you can be a little bit direct as well. Don't beat around the bush too much. People get bored. And Any other questions? Yeah.
Maybe it's too broad, but usually when you get interviews, you first talk to HR and then technical engineers. And those technical engineers, they understand what you did and they know that you're interesting, but HR people, maybe they don't understand the difference between someone's project and someone, and what are the differences between those two and what they imply. So what would you suggest? Maybe it's too broad.
So, yeah, I have an issue with that myself. I think that's really kind of a bad reflection on the companies. I know it's how things are done, and that is HR scanning a CV, we'll say, before the candidate gets an interview. And a lot of the times, your rejection letter will just come from HR, right? And like you said, they don't understand what you actually do because they're not technical. So the best thing you can do, go to ChatGPT, feed it the job spec, and say, modify my CV to these keywords. That's all you can hope for. Yeah, dealing with HR is a little bit of a dark art. And there are lots of theories on how to get your CV recognized by people. But yeah, sometimes it's just, it takes like, if you're on LinkedIn and you see that this is the person hiring for the job, go into their profile, figure out what team they're on and find the manager of that team and then contact that person. Yeah, you can apply for countless jobs through HR and get rejected. And it has no reflection on who you are as an engineer or how good you are. So don't be disheartened if you do get rejection letters. It's probably coming from somebody that doesn't know how to read your CV. So just go that one step up, do a little bit of homework. Usually people will be impressed at the fact that you've gone out of your way to find out who the hiring manager is. And that usually reflects well on you. But unfortunately, yeah, just the issue with HR reading a CV is just part of industry. Sometimes going to a recruiter can help, recruitment firms. I know some people don't like them, but they can help you get seen a little bit better because they usually have kind of a relationship with HR within a company. But yeah, that's that. Anything else?
Regarding scripting, you said that was important. Like, what do you mean by scripting? What type of scripting?
So that could be scripting with like Bash or Python. So like command line scripting to, we'll say, automate the running of processes, or Python for like parsing documents and stuff like that. So just writing scripts to automate things.
Yeah.
Again, on this one, ChatGPT is your friend. So if you're looking to get a basic script for something, ask ChatGPT to write it, and then you can learn how it works from there.
Or you do a lot of scripting for testing now, so that's
Yeah, the guys do a lot for testing. Yeah.
so you need to test every night.
Yeah. And again, with scripting, it's not just like, it's like I said with learning how to code, right? It's not just the code you write, but it's learning the logic behind how do you script for testing, or how do you test, or how do you develop, right? So the language is one thing, but the logic is the anchor.
Have any plan to support other software-defined ways than TL and TLCP native?
At the moment, no. So UHD, the UHD driver is the main one that we develop for. There are kind of workarounds where you can use kind of UHD wrappers for other drivers that let you work with things like the Blade RF. But yeah, most people now have access to USRP, so it's the kind of the de facto platform. And unfortunately, as we focus more on commercial deployments, the focus will shift more to supporting RUs, not even split out USRPs anymore. But yeah, that's not to say we're not going to develop further for USRP platforms and make that more efficient on our side. But yeah, UHD is the only driver we're focusing on at the moment. Anything else? Go for it.
Developing your product in the open, which is very different than how things are done in this field, I guess.
Mhm.
You mentioned you were working with AT&T now, but is there a lot of interest from, say, old school companies to work with you?
Like Nokia and Ericsson. I mean, they're aware of us. They know who we are and they know what we do. But we're a small fish to them, and they already have their customer base. I'm not sure what benefits working with us would have. But yeah, all I can say is that they know about us, and yeah, we've had some conversations with them and worked with them on projects. So yeah, they know what we're doing. But yeah, I don't know why they would want to put our code into their products. It would be great if they did. But yeah, we have to be realistic too.
Related question: are they active in this open run? This big? They're active.
They say they are, and they sell you.
Watch, no?
And they say they are, and then they sell you a radio unit or a RAN stack, and they say it's open source, but it's this big white box, or not open source, Open RAN, but it's a big white box with all their components in it. So yes and no. I mean, they have to say they support it so that they don't look like the bad guy, but they don't want to let people in. So I think for ORAN, the focus won't be, for now at least, won't be large scale commercial deployments. It will be more small scale private deployments in places like universities, factories, other like stadiums and stuff like that.
With the quality of integration to the one that you did well, do you have any plan to like also get into the development situation or more likely rely on presidential
For the core? No, the core, we don't have any plans to develop. I mean, we're a RAN provider, so the CUD, not the core. We have a good relationship with the guys at Open5GS, or the guy at Open5GS. He's aware of us, we're aware of him. So yeah, I mean, that works very well. And he works to support our platform. So we don't have any kind of any plans to work more closely with him or directly with him, and we don't plan to do it ourselves. It would be foolish to try and do it all, especially when there's other great open source projects out there. Go ahead. No, go for it.
like recommend open source like level of Open5G. Like some kind of feature.
Yeah. In terms of commercial core networks, yeah, I mean, we in theory integrate with all of them. As for ones I recommend, depends on what you want to do. It depends on the budget. I know we work with Athanet, who are now HPE. I don't work with them, but we've worked with them on projects. So yeah, their core is pretty robust and works. If you want more information, send me an email. Anything else? No? Okay, let's then do we have time? Yeah. So yeah, let's do a demo. So we've been talking about this for nearly an hour now. But what does it actually look like to deploy a private 5G network with our code? So this is what we're going to do. We are going to connect a phone, in fact, 4 phones, to this. So this is a software-defined radio. This is the USRP B210. And it basically lets you take in RF signals, it digitizes them and sends them to our code. And then our code can do the stuff and send the data to the internet and let you access the network in the easiest explanation I can give. If you want a detailed breakdown of how the USRP works, head over to their documentation. It's very good. I know the guy that writes it. He does a great job. But yeah, so what do we need to do this? Sorry. So that's the hardware we're using, the phone and the USRP. We also have my laptop here. So on that, we're going to be running srsRAN project, so our code, the latest version. We are not going to be using a Docker for the 5G core. That's actually running bare metal, so that's just running my PC, not in a Docker container. But we will be using Docker for the InfluxDB and Grafana, which is our kind of graphical our GUI that displays what's actually going on with the phone. Then for the hardware, like I said, we have the PC, we have the B210, and we have the UE. In the phone, we also have these. So you need a SIM card, right? Everybody has a SIM card. Some people have eSIMs. For this, you cannot use a normal SIM card. You have to use one of these. It's a programmable SIM card. So every phone has one in it already. You have to do some configuration of the SIM card to get this to work. But it's just a script that's provided by the provider. Okay, cool. So we're going to connect the phone to the network, and then we're going to do a speed test. And that's about all we can show. We could make a phone call, but it would have to be over WhatsApp, and you could browse Instagram if you wanted to, but we're not going to do that. Okay, let's see. Get rid of this. All right. Can all enjoy that lovely photograph. Let me get this up. Just talk amongst yourselves there for a minute while I get this working. Okay. So the good news is it worked earlier, so you should all be able to see something nice. So what I'm going to do is I'm going to actually display the phone up there so that you have a better idea of what's actually happening. Sorry, this is the very unprofessional part. Right. That. All right, cool. So, right. So to actually get this to work, we need to configure the gnode B, and we do that using a YAML file. So this is pretty simple. There's not a lot to it. These things here are commented out. So there's some other stuff up there. So what we're doing is we are configuring the SDR here. At the very top, we are setting the addresses for the core network so that the gnode B knows, so the CU and the DU knows where to look, the CU knows where to look for the core. We're then configuring the cell. So this is setting up a 20 megahertz cell in band 78 at about 3.41 gigahertz. We're using what's called test PLMN. So this means that the network doesn't appear to other phones as a real network. It appears as a test network. And that is all. I think that's very interesting there. Yeah, down here then we're just setting the metrics to be sent out to a specific port, which will then be read by the database and then displayed on the Grafana interface. So pretty simple, right? It may not look it to some of you, but it's pretty simple. Right. So what does this actually do? So start this. Okay. So the software is going to start up. Right now it's just configuring the radio. It has to tell it to use certain parameters, set up a cell like this, blah, blah, blah. This takes a little bit because it has to flash the FPGA on the in the radio. Okay, cool. All set up. And so you'll see here, these are all our cell parameters. So telling us that we set up a 20 megahertz cell at 3.41 gigahertz and some other information. So 1T or 1R, that means that we're transmitting with a single antenna. Or not single antenna, but single chain. Okay, so I'm going to do this, and you'll see this in a second, and hopefully it just works out of the box. Okay, so we're going to put the phone in airplane mode, take it off airplane mode, and now it's connected. That's it. I have my own private 5G network. And then I'll do a quick speed test, because this is about all I can show you right now. And that's it. So you'll see these various metrics are readable, but don't give you a lot of information maybe immediately off the bat. So we'll just let this finish and then we'll run it again, but this time we'll show the GUI. So yeah, pretty good, right? Yeah, from here then you can use the phone as normal, send WhatsApp messages, browse Instagram, browse the web, watch YouTube, whatever you want to do. So this is the Grafana output that we have. So this is basically just a visualized version of what we're seeing on the trace. And it's not working. 1 second. So sometimes this does drop off and we just restart airplane mode or reset airplane mode.
How many ports you can handle?
Up to 64. So we're going to run the test again. So you'll see the bitrate go up in the downlink because we're doing the download speed test. You'll see things like the MCS on the right, the downlink and the uplink, and the channel quality indicator on the right, and also the signal to noise ratio. So now you'll see the uplink start to go up. And as usual, the uplink is a little bit slower than the downlink. This graph isn't the cleanest. That's because we're in a room where there's lots of interference, right? Also, this isn't like the optimal setup for this. In theory, what you would do is, if you were looking to maybe create a more optimized deployment, you would run some tests and then change things like the gain of the radios or the antennas, so like how sensitive they are to information. You would change that, find the optimal conditions, and you'd look at things like how stable the MCS is, how stable the CQI is, and then what sort of bit rate you're getting and how stable that is over time. So that's pretty much it. What we're going to do now is I'll give you some phones. You can toggle airplane mode and turn them on here, Eric. You can have one.
Here's it. I mean, they said.
They're all not. This will be the real test. So the phones, they're unlocked. So all you got to do is toggle airplane mode. You'll see in the top right, it should connect to what looks like a normal cell. And what we'll do is we'll look at this, and we'll see we should get kind of 3. So we have 3 connected right now. And then if I reconnect mine, we should have 4. Yep. So you can see 5, 8, 7. Someone disconnected? Who's on it? And if we look at this, we'll see various lines of various colors. Those phones are university property, so don't do anything silly on them. So yeah, you can see the various lines with the different colors. Those are just all the phones transmitting. So if you have a phone, go and do, I think the Ookla app should be on the phone. So just go into that and run a speed test, and you'll see the phones are all connecting. The one at the back may not connect that well because the radio's down here. I connect a bit better. So that's it. That is a private 5G network in about 5 minutes. Does anybody have any questions on this?
Maybe you create a material, but you talked earlier about your projects and airborne piece. You know, like what kind of organizations you have made on the control plane and the use of plane communication to the point of which.
Okay, so just to clarify, none of the G-Node Bs are actually airborne. So for on the aircraft, so for AST, the air-to-ground network, the G-Node B is on the ground at various stations. There's a UE on the plane that basically creates a Wi-Fi hotspot and lets you connect. For AST, the G-Node B is on the ground on a site, and the satellite is basically a massive relay. If you were to put the G-Node B in space, which is possible, it's quite difficult. You have to do a lot with kind of ruggedizing the platform and all that kind of stuff. So it's not an easy task. Yeah, does that answer your question? Good. Anything else? Yeah.
I was just wondering, for having the graphs, like I use with trace, but how do you get to the graphics?
So I will show you. Let's do it this way. So if you go to docs, so you go to the documentation, not the 4G one. That is old. Let's see. So it's all in the source code. So you just go to this Grafana metrics GUI, and all you need to do is enable it in the console, or in the configuration file rather, and then run this Docker compose from the main build folder, or not the main build folder, the main folder for srsRAN. And it'll just come up. At least it should. You may need to change the command to Docker-compose, depending on which version of Docker you're using. But yeah, if you run into any difficulties, you go on the discussions. I think somebody else has had some issues with it, and it's been sorted out. And then you just navigate to that address, and it'll pick it up. And it's not too computationally intense, so it shouldn't affect the running of the code. Anything else? No? Okay, that's it. Thank you.